a lot of what we've already done in objectives 1 through 4, which is going to be great review for you. The only thing that's going to be different is we're going to be working with what we call radians instead of degrees. So everything you learned in 1 through 4 is going to continue to apply, and we're just going to be using a different unit of measure. So that is going to be nice for us. So when we are looking at measurement, we have different ways to measure, right? So when we are looking at distances, we can measure something in miles, like I just ran 1 mile, or we can talk about kilometers, like, oh, I just ran, 3 kilometers. And so when we're working with angles, we have different measures. We have degrees, which is what we're most familiar with. And then now we're going to work with radians. And so initially the radians are going to be a little bit uncomfortable, but the more you work with them, the more familiar you'll become. And so how do we define a radian? So 1 radian is when the length of an arc is equal to the radius of the circle. So when I look at this circle over here, for example, and I want to see the radius of the circle. So that would be from the center of the circle. Well, that's nice and straight. So from the center of the circle to the edge of the circle, that is our radius, right? So when I go from here to here, that is what we call the radius of a circle. And then when I go along the edge of a circle, so if I go the full distance around a circle, we call that a circumference, right? But when I only go a partial way, that is when we call that the arc length. And so when those distances are equal to each other, we generate a unit measure of 1 radian. And so, for example, if this arc length was, say, 5 inches, and this radius was also 5 inches, they are going to be equal in length when it opens up this span of this angle as 1 radian. So if we look at that, so 1 radian is about this size. Like that is what, like that's my best guess for what 1 radian looks like. That is quite large compared to 1 degree. Like I can't even draw what 1 degree looks like. Like there's my best. Like that's even bigger than what 1 degree actually is. Because I know that I can fit 90 of those degrees in between here and here, right? So this certainly is much bigger than it really is. So you can see that when I talk about 1 radian, it is a whole lot larger than 1 degree, okay? All right, so let's talk about some equivalencies because we'll use these a lot. So when we go around a circle, so when we do a full rotation of a circle, in degrees, that would be 360 degrees, right? So 1 full rotation is 360 degrees in a circle. And so a radian is 2 pi radians. And that goes into that whole, like we know, circumference of a circle is 2 pi r being the radius, right? And so when we do a full rotation, we are doing 2 pi radians. So that means 1 full rotation in degrees is 360. 1 full rotation in radians is 2 pi radians. So that means a half of a rotation is 180. So a half of a rotation would be 1 pi radians. So when I open up, right, and I do from here to here, that's 180 degrees, or that is 1 pi radians. So one thing I want you to pay attention to is that when we talk about degrees, we always use that open circle and a superscript, and that represents the symbol for degrees. And then radians doesn't have a symbol, so that lack of a symbol implies that we're working with radians. So we don't have to write out the word radians. We don't even need to put an R after that. We're just saying when we write 1 pi, we know that we're talking about radians. Okay, so the lack of a symbol implies radians. All right, so let's go ahead and label our quadrantals in radians, just like we did with degrees from the first objective that we did in this unit. So when we are going in a positive rotation, remember that we're always starting at the x-axis. So here's our x-axis. And because we're going in a positive rotation, above the x-axis is 0, and we're going to rotate upwards, right? So that's counterclockwise. So I'm going to do a full rotation first. So if I were to go all the way around the circle, remember that is 2 pi radians. So 2 pi radians, which remember is the same as 360 degrees. So if I do half of a rotation, so if I do half, so half would be over to here. So half of 2 pi is 1 pi. And we don't often put the 1 here, right? Just like when we talk about 1x, we don't put a 1 there. So we have 1 pi, or we can just say pi, right? So that would be the same thing. So then now what if I do half of that? So what is half of 1? That would be 1/2 pi. So then the upper quadrantal is 1/2 pi. But oftentimes we'll just write that as pi over 2, right? So if I put this over 1 times pi is pi, 2 times 1 is 2. So the preferred way to write it is pi over 2, but of course 1/2 pi just means the same thing. Okay, so let's talk about what if we want to do this lower quadrantal. So now in the past, we would say, hey, that's 90 degrees, right? And we would count by 90. So that's 90 degrees, and then another 90 makes 180, so on and so forth. But now because we're working with radians, we have to count by halves, right? So because this is a 1/2 pi. So when I'm counting here, so I don't think of that as 90 degrees, I now think of it as 1/2 pi. So that's 1/2. This will be 2 halves. So 2 halves, right? And then another half would be 3 halves. And then another half would be 4 halves, right? And then if I were to reduce 2 divided by 2, that gives me 1 pi. 4 divided by 2, that gives me 2 pi. So we count by 1/2 to figure that all the way around. Okay, so just to clean this up just a little bit, so we know that we don't have, we don't write it as 2 halves, right? So we'll just write it as 1 pi or pi. And then pi over 2 is, again, our preferred. And so with that being said, then that means we have a preferred on this one as well. So 3/2 pi, again, is perfectly fine. But typically, we would write it as 3 pi over 2, right? Put that over 1. So 3 times pi is 3 pi. 2 times 1 is 2. All right, so we're going to do the same thing now for this one. So this time we're going to go in the negative rotation. So whenever we do that, again, we always start on the x-axis, positive x. But then because we're going to go in a negative rotation, our 0 is going to start below. And then we're going to rotate this way for negative. So let's do that full rotation first. So 1 full rotation is 2 pi. Oops, let's fix that. What's happening? There we go. So 1 full rotation is 2 pi. So this will be 2 pi, but we went in a negative direction. So then what is half of 2? Half of 2 is 1. So then halfway around would be here. So that would be negative 1 pi or negative pi. So that is half of a rotation. And then what's half of 1? So half of 1 is 1/2. So then this would be 1/2 pi. But again, we're going in a negative rotation. Or we can write it as negative 1 pi over 2. Same thing. So then once we do that, we know that we're going to count by halves. So every time we go through a quadrant, we're going to go 90 degrees. Or in this case, we're going to go 1/2 pi. So from here to here is 1/2 pi. So this will be 2 halves, 3 halves, and then 4 halves. But 4 halves is the same as 2. And then again, we can write that as negative 3 pi over 2. Okay, so let's do a little summary here. So if I were to mark this measurement here, how many degrees would that be? It would be 90 degrees. If I want to switch the unit of measure, how many radians would that be? That would be 1/2 pi radians or pi over 2. Okay, so when I ask you how big is this, you can either say it's 1/2 pi radians or it's 90 degrees. All right, so let's do a few examples here. And then again, this is reviewing off of objective 1. We're just doing a different unit of measure. So for this here, they want us to sketch an angle, and they want us to make sure we're in standard position. So you can see all 3 of these are a positive rotation. So then I'm going to put this as 0, right? So always on the x-axis, there's my 0. And so if I do 1/2 of a rotation, so this would put me at 1 pi. But because we have different denominators here, do you see we have a denominator of 8, a denominator of 6, and a denominator of 5? What I want to make sure that I'm doing is I want to get a common denominator so that I can make sure that I'm sketching accurately. So what I'm going to always do is I'm going to take that denominator here. So in this case, I'm going to take that denominator of 8, and I'm going to get a common denominator with that 1 pi. So that means instead of pi, I'm going to write that as 8 pi over 8. Because what is 8 divided by 8? That is just 1, right? So those cancel, that reduces. So, but I want to keep that denominator. So whatever this number is here, I'm going to always make sure that they match, right? So if this is a denominator of 8, I'm going to make that 8 over 8. And that will make it a lot easier for me to kind of work out where does 3 pi over 8 land. So then just like I did up above, I'm going to work through that same process. So what is half of 8 pi over 8? So half of 8 is 4. So then this would be the same as 4 pi over 8. And so 4/8 is 1/2, right? So I know that's 1/2 pi. So now I'm going to count by 4s to label the rest, right? So this is 4 pi over 8. And then another 4 would make that 8 pi over 8. And then another 4 would make that 12 pi over 8. And then another 4 would make that 16 pi over 8. And if I were to check all of these, it reduces to what we came up with on these quadrantals, right? So 16 divided by 8 is 2 pi, okay? All right, so then once I get that done, I just now need to figure out, okay, well, where does 3 pi over 8 land in between? Is it between the 0 and 4 pi over 8, or between 4 pi and 8 pi over 8, right? So now I'm just trying to figure out where does 3 pi fit. So 3 pi is somewhere between 0 and 4, so then I would draw 3 pi over 8 here in quadrant 1, right? So that would be in quadrant 1. All right, so let's take a look at the next one. So again, I'm wanting to start out on the positive x-axis at 0. And then I see that I have a denominator of 6. So when I do this 1 pi over here, so 1 pi is the left quadrantal, I want to get a common denominator of 6, so I'm going to make that 6 over 6. And then I'm going to take half of 6, so half of 6 is 3, with the matching denominator. And then now I'm going to count by 3s. So this would be 3 pi plus another 3 pi would make that 6 pi, plus another 3 pi would make that 9 pi, plus another 3 would make that 12 pi, always keeping that common denominator. So then once I do that, I want to see, okay, where does 7 pi land in between? And 7 pi is somewhere between 6 and 9. So when I draw that quadrant, or draw in that standard angle, I'm going to draw that in quadrant 3. And so that is where 7 pi over 6 would rotate to. Okay, so let's do one more here for this style. So I want to get that common denominator of 5. So we'll start over here at 0. This is normally pi, but we're going to make it 5 pi over 5. And then I'm going to take half to find that top quadrantal. So half of 5 is 2.5. And then I'm going to count by 2.5s. So that's 2.5. Another 2.5 is 5. Another 2.5 is 7.5. Always keeping that over 5, that common denominator. And then another 2.5. And then you can always double check, right? Is 10 divided by 5 is 2. So I know I did that right because that would be 2 pi. So then once I do that, I want to try to figure out where does 3 pi land in between. And 3 pi is somewhere between 2.5 and 5. So then I would be in quadrant 2 for 3 pi over 5. All right? Okay, so you'll get plenty of practice with labeling those quadrants and working with those fractions. All right, so let's take a look at the next section. So for here, we want to find a reference angle. So just to review, what is a reference angle again? So a reference angle is that shortest rotation to the x-axis, and it's always to the x-axis. So the nice thing is we're not going to have to label the y-axis, we're only going to have to label the x-axis. And then another reminder is a reference angle is always going to be positive. Okay. All right, so all we're doing is looking for that reference angle, and we're going to start out the same way we did on the previous problems. So here we have a positive rotation, so we're going to start on the x-axis and we're going to label that 0. And then I have that common denominator of 4. So instead of just calling that pi, I'm going to call it 4 pi over 4. And then I don't need to label the quadrantals on the y-axis because the reference angle is only going to go to the x, right? Only going to go to the x. So let's finish labeling. So I know that 0, this is 4 pi, so we'll go another 4 pi to make this 8 pi, right? So this one should always be double, right? So if this is 4 pi here, another 4 pi gives me 8 pi. So then once I do that, I want to figure out, okay, which way am I going to head to get to that shortest distance to the x-axis? So if this is my angle here of 5 pi over 4, do I want to keep going forwards to 8 pi? Is that the shortest distance? Or should I backtrack over here to the negative x side to 4 pi? So which one is the shorter distance? And it's going to be this one here, right? So that is my shortest rotation. So then now I just need to find, what is that gap? So what is the gap between 5 pi and 4 pi? How far apart are they? And they are just 1 pi away from each other with that common denominator of 4. So remember, the symbol for reference angles is we use the theta, so that circle with the line through it is theta. And then when we put that apostrophe on it, we say prime. So then theta prime would be 1 pi over 4, and of course we don't need to have the 1. Okay, so let's go ahead and do another one here. So for this one here, so we're looking for 11 pi over 6, so also a positive. So we're going to count 0 here. And then we know to the left is pi, but we want a common denominator of 6. So that would be 6 pi over 6. And then we're going to double that. So that would be 12 pi over 6 here, right? So if this is 6 pi over 6 to there, another 6 would make that 12. So then now we have that 11 pi over 6 is down here in quadrant 4. And then to find the reference angle, we're always going to go to the x-axis. So I'm going to highlight my x-axis. And I want to figure out what is my shortest distance. So for my shortest distance, I want to figure out which way should I head. Should I keep going forwards to that 12 pi over 6, or should I backtrack over here? So which one is a shorter distance? And it's going to be the one to 12 pi over 6. So this is a shorter distance to get to the x. So how far apart is 12 pi over 6 from 11 pi over 6? They are just 1 pi away from each other with that common denominator of 6. Okay, let's get another one in here. So this one's going to be a negative rotation. So that means when we label, we want to start labeling below the x-axis, right? And so then when we head over here, this is normally pi, we're going to get that common denominator of 7, but we're also going to mark that negative, right? So then, I think this is drawn in the wrong quadrant, I just realized. So negative 4 pi over 7, that's in the wrong quadrant. Okay, so we'll fix that. So where should negative 4 pi over 7 be? So negative 4 pi over 7, so let's ignore this. This is in the wrong spot. So that should be somewhere over here. So let's draw that. Let's fix that mistake. So there's negative 4 pi over 7 there. Okay, so now I need to figure out where is my shortest rotation to the x-axis. So let's fix that. So I can see that that shortest route is just to come this direction, right? So that is definitely a lot quicker than trying to backtrack to the 0. So then I'm looking to see, okay, how far apart is 4 pi over 7 from 7 pi over 7? Remember, we're doing reference angles. We want to look at that absolute value piece of it. So even though those are negative rotations, we think of reference angles always being positive. So we're ignoring those negatives. So how far apart is 4 pi from 7 pi? And they are 3 pi apart from each other. And even if it's a negative rotation, we still use positive values for reference angles. All right, so let's go ahead and move on to the next set. So we're not going to do all of these examples here because it's just kind of repeating what we've already done. So we're going to kind of jump around a little bit and see how to do these different ones. So here we're going to pull together all of those ideas. So we're going to sketch just like we did in the first group. We're going to identify quadrants. So just as a reminder, when we're looking at our quadrants, the upper right-hand corner is always quadrant 1. And then we rotate in a positive direction for the rest. So this would be quadrant 2, quadrant 3, and then finally quadrant 4. Okay, so we're going to skip 9. And then let's take a look at example 10. So this will be a good one for us because we're going to be reviewing, looking at negative rotations again. So negative rotation, so here's my x-axis. So negative, I'm going to label 0 below. And then this would normally be negative 1 pi, but I want to get that common denominator of 8. So we'll call that 8 pi over 8. And so we do want to label all of the quadrantals just because we're having to graph it. So we'll take half of negative 8, which is negative 4 pi over 8. So we're not going to draw it up here. We're going to draw it down here because we're going in a negative rotation. So half of 8 is 4. So that's why we have the 4 pi over 8. And then now we're going to count by 4s. So this is 4 pi over 8. And then another 4 would be 8 pi over 8. Another 4 would be 12 pi over 8, but of course negative. And then another 4 would be 16 pi over 8 and negative. So now what I want to do is I want to figure out, so where does negative 5 pi over 8, where does it land, right? So what is 5 pi over 8 in between? And it's in between 4 pi and 8 pi. So that means I'm going to draw negative 5 pi over 8 down here. And then that's in quadrant 1, 2, 3. So that would be in quadrant 3. So the reference angle, we want to do the shortest distance to the x-axis. So here's my x-axis. And so which way would I head to make that shortest route? Would I backtrack to the 0 or would I go forward to that 8? And going forward to the 8 would be that shortest distance. So that's what I'm going to take a look at. So how far apart is 5 pi from 8 pi? Remember, we're doing positive values only for reference angles, right? So how far apart is 5 pi from 8 pi? And that is 3 pi over 8. Okay, so let's take a look at question number 11. So for this one here, so we're going in a positive direction. So I'm going to call this 0. And then I want a common denominator of 3. So instead of calling that pi, I'm going to call it 3 pi over 3. And then half of 3 is 1.5. So this will be 1.5 pi over 3. So I'm going to count by 1.5. So there's 1.5 pi. And then another would be 3 pi. And then add 1.5 to that. That would make 4.5. And then add another 1.5 to that would be 6. So 6 pi over 3. So then now what I need to do is I need to look to see, okay, so where is 7 pi in between? It's in between none of these, right? It's certainly not in between 3 pi and 4.5 pi, right? It's definitely not between those two. It's not between 4.5 and 6 either, right? So it's bigger than that. So what does that mean? So that means that 7 pi over 3 is actually, it's making a full rotation and then it keeps going, right? So how far beyond it does it go? So if this is 6 pi over 3 and we want to go 7 pi over 3, it's going to go 1 pi more. So which is less than 1.5, right? So 1 pi. So it's only going to go 1 pi more. So that means it's going to land over here in quadrant 1. Okay, so one more time. So 6 pi over 3 is a full rotation plus 1 more pi will put us at the 7 pi over 3 in quadrant 1. So my reference angle is this distance here, right? That positive rotation. So how far away is 6 pi over 3 from 7 pi over 3? That is 1 pi over 3. Okay, so we're going to do 2 more here. So let's take a look at pi over 9 we'll do. So we'll skip another negative. So we'll do 13 and 14. Okay, so pi over 9. So we're doing a positive rotation, so that would be 0. And then over here, this is 1 pi, but we want a common denominator of 9. And then I'm going to take half of 9, which is 4.5. And then I'm not going to go any further because I can already see that if I'm trying to get to 1 pi over 9, it's somewhere between 0 and 4.5. So that means 1 pi over 9 is going to be somewhere here, 1 pi over 9, which is in quadrant 1. And so where is my shortest rotation to the x-axis? So that's how I always find my reference angle. So which way would I head? Should I backtrack to the 0 or keep going forward to 9 pi over 9? So which one is that shortest distance? And it's certainly going to be backtracking to the 0. So how far apart is 0 from 1 pi over 9? Well, it's going to be 1 pi over 9 or pi over 9. Okay, last one here. So this one, we have a negative rotation, so I'm going to drop 0 below the x-axis. Normally this would be negative 1 pi, but we want a common denominator of 2, so that would be 2 pi over 2, but we'll make that negative. And then half of negative 2 is negative 1, so then this would be negative 1 pi over 2. So remember, going negative, so drop down to the bottom. And so this time we're going to count by negative 1 pi. So this is negative 1 pi over 2. Another one would be negative 2 pi over 2. Another one would be negative 3 pi over 2. And then finally, last one, negative 4 pi over 2. So then normally I would ask that question, like, where does negative 3 pi over 2 land in between? But it doesn't land in between anything. It's actually a quadrantal. So when I draw this in, it's going to be on the y-axis, right? So on the y-axis. And so it's not in a quadrant, right? So this does not apply because it's not in a quadrant. And then my reference angle, as far as I'm, looking at this and I'm like, hey, which way is going to be faster? Should I drop to the x-axis going to 2 pi or 4 pi? And it's equal, right? So normally we wouldn't always give a reference angle for a quadrantal, but we're going to go ahead and do that for this one. So it doesn't matter which one I go to because 3 is 1 away from 4 and also 1 away from 2. So my reference angle would just be 1 away with that common denominator. And that is the end of Objective 5.